All right, in this video we're going to pick up here. This is part 2 of creating an Involute gear tooth and gear. So we already created in part 1 this gear tooth profile, and now we're ready to continue to develop that tooth. So what we're going to do is we're going to grab our, first of all, let's go back to the PowerPoint and take a look. So we'll slide down here. We've done big R and little r, and now we're ready to construct the rest of this gear tooth. So we need to get a line, a straight line that's going to be drawn from the base circle to the dedendum circle. Here's a close-up of what that looks like. So from the base circle down to the dedendum circle, and that is going to be a radial line from the center. So we'll jump back out here to Inventor, grab our line tool, zoom out so we can then grab the intersection of the little r arc and the base circle, and then draw a radial line down to the center of the circle. So then we'll go ahead and trim back up because we don't need this inside portion of the line, but we needed this line right here. So we're going to go ahead and leave that line. That pretty much takes care of that one side of the tooth. So now we got to go ahead and create the other side with a mirror operation. So we'll jump back into the directions here. And what we need to do is we need to come up with the tooth spacing. So to do that, we need to take a look and come up with an angle first, and we do that by coming up through this formula. Here we have the angle equals 360 in degrees divided by 2 times n. Well, n is the number of teeth. So we're going to go ahead and take the number of teeth, which is 20 for this gear, and it was given to us back in the beginning of this PowerPoint, and we're going to multiply that by 2. We do the order of operations here, parentheses first, that gets us to 40, and then we divide that by 360 degrees, and we come up with 9 degrees. So the angle that we're going to utilize for the other side of the tooth is 9. However, in order to come up with a mirror line, we need half of that. So we're going to use 4.5 as the center line for our mirror, and then we'll mirror the gear tooth to the other side. So we'll do this over here in Inventor. Well, we'll grab our line tool, and we're going to go ahead and draw a line. And that line is going to be 9 degrees from the point P line that we drew back in the beginning. So I'm just going to go ahead and draw a line, and I'll grab my dimension tool and dimension to that line. So this is about 13 degrees. So I'm going to go ahead and make this 9 degrees. And then I'm going to do the same thing again, and I'm going to draw a second line, and that line's going to come up, and this line is going to be then dimensioned. And that's going to become 4.5. So this will be our mirror line, and this line is going to show where the tooth should show up. So now we're going to go ahead and grab the mirror tool, and the geometry that I want is the big R, I want little r, and I want this straight tooth line. My mirror line will be this portion, this center line here, and then I hit apply. I can see now that the tooth has been mirrored and it's linking up with that 9-degree line, so it worked. Hit done. Now we're ready to continue to move forward and clean up this drawing because there's a lot of erroneous geometry that we are not going to use. So we're going to then go ahead and trim and clean up a lot of the geometry. But first, let's go back to the PowerPoint. It's exactly what it says. Trim and delete all unnecessary construction geometry, keeping the pitch diameter circle for assembly constraint purposes if you plan on using the gear. So what we really need here is we need this geometry and the pitch diameter circle and the inside dedendum circle at this point. So from that, we'll grab our trim, and we want to start tidying up and cleaning up this gear tooth. So then we'll go ahead and we can actually, well, after that, I think we can start deleting. So I can delete this line, I can get rid of this line. I do not need the outside addendum, but I did need to trim here to then clean up the outside addendum for the tooth top. We'll go ahead and get rid of the rest of this information here. We don't need this line. I'm keeping this outside circle. This is our pitch diameter that was given to us in the beginning of 5. We do not need the base circle, so we can get rid of, whoops, wrong button there. We can get rid of this base circle and clean that up. So now I believe we are going to be ready to start looking at extruding this tooth. All right, to do that extrusion, I'm going to finish that sketch, and I'm going to grab my extrude tool. Now I'm going to mouse over these parts, and it looks like we have a nice closed loop. It's seeing that everything is cleaned up here and trimmed off nicely. I can go ahead and select those two pieces of geometry to create this gear tooth. If for some reason you do not have a gear tooth that is extrudable, most likely the problem is coming into play down here at the bottom of your gear tooth, where you need to have a closed loop across this point. You can recheck your position and the trimming of these two radial lines for the straight gear tooth. The other thing you can also do, and this is in the directions, is you can create an arc, and you can use the center point arc tool to do this. And this is where you would then create an arc from the center and then draw across the bottom of the gear tooth. And I'll just show you how to do that. It's not necessary for me to do it this time, but if you needed to, you can grab the arc, grab the center point arc tool, find the center of this whole assembly gear, and then click and draw an arc to the other side. So if you needed to do this, you needed to create an arc, you could go ahead and do that, and then that would have created the bottom geometry and cleaned it up so that you would have a closed loop. If then you were still needing an issue and you couldn't extrude, you could then right click on a piece of geometry and you can go into closed loop. What that will then also do is you can work your way around, making sure you can select all the geometry around this part to close up the loop. All right, and you would then click on that bottom arc. So that wasn't necessary for my assembly right now. I'm sorry, for my extrusion, because it's recognizing it. But if you needed to, you can do that. And that information is all here in the PowerPoint. All right. So now we're going to go back in here and we're going to extrude. But first we want to say that we want to extrude this gear tooth separately from the actual center portion of the gear. And there's a reason why we want to do that. So first I'm going to extrude this gear tooth, and I'm going to go ahead and just make this 0.25 thick and hit OK. Then we lose all the other geometry, so I need to hit the plus symbol underneath of my extrusion one, get to my sketch, right click and make that visible. With that being visible, I can then go ahead and extrude the center portion. Now the only thing missing is a center hole, so I'll jump back into that sketch and I will create a center hole that if we were going to utilize this gear for something, we could do that. All right, so instead of doing that, we'll do that to be 0.5 in diameter. So we'll finish up the sketch, grab the extrude tool, and then I can select the center portion, making sure it's 0.25 as my extrusion distance, and hit OK. So now with that set up, I now have a gear tooth on the outside of a circle. Now I'm ready to go ahead and set up the fillets for the tooth fillets and then the rest of the array. So we'll go back to the PowerPoint. All right, so to do the radius, we're going to go ahead and come back to the PowerPoint. We're going to go ahead and set up the fillet radius, where we use some formulas again, 1.5 times clearance. And 1.5 is a standard value to create the fillet radius, whereas clearance, though, is the distance that occurs between two teeth when you have two oppositional mating gear teeth. So that is where clearance comes from. And the clearance distance comes from the formula 0.157 divided by P, where P is your diametrical pitch, and that is equal to 4 in this gear. So we're going to take 0.157 divided by P, then we're going to come up with the solution there at 0.03925. Multiply that by 1.5, and then we get our fillet radius here of 0.05887. So that's the fillet radius that we're going to go ahead and put into Inventor in our fillet tool. So we'll go ahead and slide back down over here to Inventor, and we're going to go ahead and set up our fillet and put that information in here. So 0.058875. I believe that might be correct. 0.058875. 0.058875. That's correct. So then we're going to zoom in here and we're going to select the back side and the front side here, what I can see of my gear, and hit apply. So I can then hit cancel, and we can go ahead and continue to build out the rest of our gear here. So we'll do that by using our array tool. So we'll grab the circular pattern tool, and I'm going to go ahead and grab the gear tooth. We're going to go ahead and grab both fillets, and then we're going to go ahead and set up the rotational axis. So we'll grab anything round, anything that's going to go around. It could be the center, it could be the outside. It doesn't necessarily matter. And we'll go ahead and set up the number of teeth, which is going to be 20 because it's a 20-tooth gear, and we hit OK. Then all that's left to do is to save out our gear, because now we can utilize this gear in different assemblies. So we'll do just file save them, and I always suggest that when you go ahead and save these things, save them based upon the original information that you started with in the gear. So when you want to go ahead and save this thing out, and this is, again, there's your array in the PowerPoint and then the final gear. But if I come up here in the beginning, we started making this gear with a 5-inch pitch diameter, 20-degree pressure angle, and 20 tooth. You want to save that with that information. That way you know the gear that you're actually going to pull up when you go into your file structure to find your gear. So go ahead and save that out, and next video we'll talk about how to build a mating gear.